Text analysis is the process of deriving information from text data that may come from sources such as social media or news articles. This data can be evaluated using machine learning tools, but will require that the unstructured data be processed and organized so that it could be analyzed. The term corpus is often used in the text analysis world, which is the collection of text that's being investigated. The term corpora is a plural form of that. Many analysis techniques can be done on a corpus, which include but are not limited to things such as analysis on word and sentence counts, specific mentioned topics, language detection, and understanding the sentiment of text at different levels. One popular Python library used for text analysis is called TextBlob. It is considered to be a text and natural language processing library built on top of other NLP libraries called Pattern and Natural Language Toolkit. One advantage to TextBlob is that it's very easy to learn when compared to other NLP libraries. Some of the tasks that TextBlob is capable of doing is shown here on this slide. Many of these will be demonstrated in later slides. Another popular library for text analysis is called WordCloud, which makes it possible to visualize qualitative data. The image shown here is an example of a word cloud coming from an Amazon reviews dataset for a particular product. The natural language processing libraries do not come pre-installed in Anaconda, unlike with Pandas, NumPy, Matplotlib, and Seaborn. I will provide instructions on how to install these libraries that are needed for this module as we go through some examples. To install TextBlob, you will want to go to the Start menu on your computer and search for the Anaconda prompt application. Once the prompt screen is open, input the syntax in red shown in step 2 and then press enter. After that installs, enter the syntax in step 3, press enter again, let it do its installation. Afterwards, you can exit out of the screen, and then now you are capable of importing the TextBlob library in Jupyter or in Spider. Okay, let's take a look at how to use the TextBlob library. Keep in mind that the TextBlob is an object that is similar to a string data type, so it could use the standard Python string methods. The standard way to import a TextBlob object is shown in line 1. Pay close attention to how TextBlob is capitalized. The text variable in line 2 contains a string with 2 sentences, and in line 3, the blob variable stores the TextBlob object containing the text variable with the string. When using the type function on the blob variable, the output shows that this is a TextBlob object. A TextBlob object is capable of performing operations on strings that are stored inside of it. It is possible to split the string by words or by sentences. This is called tokenization. Here we have an example of sentence tokenization and word tokenization. The first cell illustrates how to tokenize sentences using the sentences attribute on the TextBlob object called blob. The result is a list of sentences. Next, we have the words attributes, which breaks up the sequences of text by words as shown here on the third cell. But the result is a data type called word list, which is an extension of Python's standard list data type. Another text analysis technique is extracting the topics discussed in the text using the attribute noun_phrases. This will result to a words list displaying all the different noun phrases in the text. Depending on the text, the attribute will determine if each noun phrase item will contain a single word or multiple words. In this example, the output happens to be 2 noun phrases with multiple words. Okay, let's take a look at some more examples that we can do when it comes down to doing some text analysis techniques on a corpus. So here we have an example of using Python's len function on the blob's sentences and words to get their respective counts from the corpus. The TextBlob object has a words count attribute that returns the number of occurrences a word appears in the corpus. An alternative method is to use the count method as shown in the third code cell, which is used on the words attribute of the TextBlob object. The deletion of stop words may be needed when analyzing a TextBlob object. Stop words are common words that do not provide useful information. To remove stop words, we must first import the Natural Language Toolkit library as shown in line 1. Enter the syntax shown in line 2 to download a list of predefined words. This could be done using Jupyter or Spider and only needs to be executed once. To view the list of stop words, you will need to import the stop words object from the NLTK library as shown in line 1. In line 2, we have a print statement that will display all of the stop words defined in the English language. The output shows the stop words as a list and can be modified if needed. Here's an example of how to remove stop words from a corpus. Starting at line 4, the list of English stop words is stored in a variable called my_stopwords. Then in line 6, we have the TextBlob object being stored in a blob variable. Afterwards, in line 8, a for statement is provided that will iterate on all the words in the blob. If the word is not part of the stop words list, then the word will be displayed. Compare the output to the string in line 6. Several words have been eliminated or cleaned out from the text. Remember that the iterable in the for statement is the blob.words. This attribute returns a list of word tokens. If there is a need to check if a word is included in the stop words list, or if a stop word needs to be removed from the list and included in the text analysis, this can easily be done as shown here. The code cell checks to see if the word am is in the list of stop words, which returns a true value. If we want to remove the word am from the list of stop words, we would use the remove method. We can then check to see if the stop word has been removed, as shown here. Another neat feature that TextBlob offers is a built-in dictionary. To utilize the dictionary function, the word function object must be imported from TextBlob as shown in line number 1. The next line assigns the word function with the word course inside of it to a variable named course. Finally, in line 3, the definitions attribute is called, which results in the different definitions of the word course. Sentiment analysis is a form of text analysis, also known as opinion mining, where we're trying to determine the opinion or attitude of the text. This analysis technique is a component of artificial intelligence that uses natural language processing to organize the unstructured data to structured data. Sentiment analysis is used by many organizations. Businesses collect data from consumers through social media, phone recordings, emails, and chat rooms to examine the customer's view of products and services. Oftentimes, this process is automated so that executives can make fast business decisions and stay competitive. The sentiment attribute could be used on the TextBlob object, which will return a tuple of the polarity and subjectivity measures of the text. In this example, we have a text blob containing a string that states, "I am doing well in my analytics course. I am not so sure about my physics course." The outcome is a polarity score of 0.5, meaning that the corpus has a slightly positive view, whereas the subjectivity score is 0.88, indicating that the text is highly subjective rather than objective. The ranges for each measure are shown here. Polarity can range between -1 to +1. The closer it is to 0, the more neutral the tone is. For subjectivity, the range is between 0 and 1, where the closer it is to 1, the more subjective or opinionated the text is, but the closer it is to 0, the more objective it is. It is possible to extract a specific measure when doing a sentiment analysis. Here we have the second and third code cells showing how to output the polarity and subjectivity scores individually. You can think of these as sub-attributes from the sentiment attribute. We can take this a step further and get the sentiment of each sentence using a for statement. In this case, the iterable in the for statement is the blob.sentences, since it does return a list of sentences from the corpus. The result is two tuples containing the polarity and subjectivity for each sentence. Having more text data may provide better generalized results, but another factor that plays a role in sentiment analysis scores is the specific sentiment analysis algorithm used behind the scenes. Depending on the type of data being analyzed, it may be a good idea to be selective on which sentiment analysis algorithm to use, or perhaps build a classification model that goes through the training and testing process. The sentiment analysis technique done so far comes from a list of known words that are predetermined by the developers of the library. Which approach to use depends on what words are in the corpus. The table presented here comes from investigate.ai, which summarizes the different techniques and methodologies used to determine the score for a sentiment analysis. On the next slide, we will take a look at an example on how to use the naive Bayes analyzer in TextBlob. This is done by tuning the parameters in the TextBlob object. Without tuning the analyzer parameter in TextBlob, then the default algorithm for the sentiment analysis is called pattern analyzer. Let's take a look at using the machine learning algorithm. To conduct TextBlob's sentiment analysis using the naive Bayes analyzer, it needs to be imported as shown in line 2. This analyzer function object will be passed in as an argument to the TextBlob object as shown in line 4. Once the sentiment attribute is called on the blob, the output returns a tuple providing 3 items. The first is the classification tag of the corpus, which happens to be tagged as a negative sentiment. The next 2 items in the tuple represent the percentage of positive and negative sentiment within the corpus. The results from the naive Bayes analyzer differ from the pattern analyzer technique used earlier. With the naive Bayes analyzer, the subjectivity measure is not provided. Now we'll take a look at 2 possible data visualizations for qualitative data. The first one is considered a qualitative visualization called a WordCloud, which represents the different words in a corpus, but the size of each word presented depends on how frequent it occurs in the corpus. One other possible visual is a bar chart that reflects each word's frequencies in the text. This is considered to be a quantitative visualization since each bar's height depends on the number of occurrences the word appears in the corpus. Both charts depend on matplotlib to function, but the WordCloud will make use of the WordCloud library, which will need to be installed since it's not pre-installed on Anaconda. To install the WordCloud library, enter the line of code shown on step 2 inside the Anaconda prompt application. After the code executes, you can close the prompt window and your IDE can now import WordCloud objects. As a case study example, we'll make use of a few George Mason University reviews obtained from niche.com. The text data was copied and pasted to a notepad and saved as a text file. The data in the file is shown here. In full disclosure, I filtered the reviews to show only the excellent ratings, so the analysis will be based on a sample of a few excellent reviews. To load the text data file, the Python built-in function called open will be used instead of the Pandas readCSV function. A file path of where the file is located needs to be specified as the first argument in the open function. The second argument passed in is the string value in lowercase r, which means that the text file will be opened for reading purposes. The read method is chained to the function so that the contents of the text file is stored in the file variable. To make sure that the contents are stored properly, a print statement is used on the file variable as shown here. To generate the word cloud using the contents in the file variable, it will require that we use matplotlib and wordcloud as shown in line number 1 and number 2. The import structure in line 2 is similar to that of the TextBlob objects. Here, the wordCloud function object is being imported. Then in line 3, a word cloud is being instantiated to a variable called myWordCloud, which is used in line 4, where it's chained with the generate method containing the argument file. Line 5 uses the plt.imshow function on myWordCloud to display the image. The imshow function is used here instead of the plt.show function because under the hood or behind the scenes, a word cloud is stored as a multidimensional array, and the imshow function converts the arrays to a visual. The output of the code is shown here. Notice that the x-axis and the y-axis of the multidimensional array is displayed. To remove this, we would need an extra line of code, and we will see this shortly. The words that appear the most frequently in the corpus are the words that you see here in the bigger size font. There are many arguments that could be passed into a word cloud object. A snippet of the documentation is provided here. A word cloud object does have a random state parameter set to none. So anytime that the word cloud code is executed, its display will be different from the last execution. We can pass in an arbitrary integer value as an argument so that the word cloud could be replicated. This example uses the same corpus of Mason reviews, but the output shown has a white background color and the x-axis and y-axis ticks are removed. Notice that the code here in line 3 passes in 2 arguments in the word cloud object. And in line 5, it includes the code to remove the x-axis and y-axis ticks. Word cloud's generate method used in line 4 automates the processing required to generate a word cloud. These steps include things such as removing punctuation, as well as word tokenization and normalization, and this helps with the display of the word cloud. Another process that the generate method handles is the removal of stop words. Remember, these are words that are used often in the text, but does not really add value to the analysis that we're doing here, which is a word cloud. So words such as the, a, and as would be removed. Now, to display a bar chart of the corpus, it will require several Python libraries and several steps to process the data. Assuming that we have a new Jupyter Notebook file, we first need to load the data. In line 2, we have a variable containing the string of where the Mason review text file is located. In line 3, we have the open function to read the data and store it into the file variable. Next, in line 6, we have the syntax to get the frequency distribution function object from the NLTK library, which is part of the probability module. Keep in mind that we could use built-in Python code to create the frequency distribution of words in the file, but that will require too much effort and there's no need for us to rewrite the code. The last line is the syntax to import the TextBlob function object that will be used on the file containing the text. The TextBlob is created and assigned to the blob variable, which is then used as an argument in the frequency distribution function in line 11. The output is a dictionary where each word is a key and its value is the number of times the word appears in the corpus. The output reveals that there are stop words that could be eliminated from the analysis. For example, the words a, is, the will need to be removed. Recall that the stop words come from the Corpus module in the NLTK library, so we'll need to import it and store the English stop words in a variable, as shown here. Afterwards, the for statement could be applied on the blob object. Line 8 will store the words in the items variable. These are the words that are not part of stop words lists. Line 9 is the for statement header where the iterable is the word tokens. The string method lower is chained, which will convert all the words to lowercase. This is because all of these stop words are presented in a lowercase format, and this will avoid any capitalized letters or words to be treated differently. Next, the items list is converted to a string using the join method and stored into a variable called cleaned_string. This is shown on the code to the right in line number 2. Notice that the output shows the first 41 characters of the string. The TextBlob object is created using the text inside the clean string variable and the frequency distribution is displayed to confirm that the changes have been made. The word frequency variable contains a dictionary of all the clean words in the corpus. Now we can convert this dictionary into a data frame for further analysis. We must import Pandas to be able to use the pd.dataframe function and enter the arguments as shown here in line number 2. The first argument is the dictionary variable using the .items method. The second argument specifies the column names of the data frame. Line number 3 uses the sort values method on the data frame to sort the count column in descending order to be able to view the most occurring words. Finally, we import matplotlib to display the bar plot. The graphical representation here shows the top 20 words used in the corpus.